Welcome to Developer Ramp Up, a channel dedicated to anybody who wishes to become a software developer or a better software developer. In this video, we will talk about Fibonacci numbers. More precisely, we'll design and implement an algorithm that generates a Fibonacci sequence. The Fibonacci sequence is a sequence of numbers characterized by the fact that every number in the sequence is the sum of the previous two elements. It is a recursive sequence because new elements are generated by a reference to the sequence itself, without any external action. Now, Fibonacci numbers appear unexpectedly often in mathematics, so often that there is an entire journal dedicated to their study, the Fibonacci Quarterly. However, applications of Fibonacci numbers include computer algorithms such as the Fibonacci search technique and the Fibonacci heap data structure. But they also appear in biological settings. One example is, for instance, branching in trees. Another is the arrangement of leaves on a stem. And finally, we can explain the seed arrangement in a sunflower using Fibonacci numbers. There are, however, a lot of other examples in nature, economics, weather forecasts that can be described using Fibonacci numbers. Before starting with the algorithm, let's look deeper at the numbers in a Fibonacci sequence. First of all, we have to decide a starting point to our sequence. And here we have two main approaches. The one I call the older approach, since it was used by Fibonacci himself, is starting the sequence with 1 and 1. A more modern approach starts the sequence with 0 and 1. For now, we will stick to the older approach and we will start our sequence with 1 and 1. Now, coming back to the Fibonacci concept, we said that each number in the sequence is the sum of the previous two numbers. So if we start the sequence with 1 and 1, this means that our next number would be 1 plus 1. So this means 2. The next number would be then, of course, 3, which is the sum of 1 and 2. The next number would be 5, which is the sum of 2 and 3. The next number would be 8, which is once again the sum of the previous two numbers, which are 3 and 5. And then we would have 13, which is the sum of 5 and 8. And we could go this way very long. However, we will stop here since I think that we got an insight about how the Fibonacci sequence works and how numbers in this Fibonacci sequence are generated. And now we can start thinking about how to design an algorithm that would generate this type of sequence and print it to the console. Let's look first at the problem itself. So what we need to achieve is to write an algorithm that prints out the first 15 Fibonacci numbers. Now, what do we need for this? Well, we need, of course, a counter because we know we have to print out only the first 15 Fibonacci numbers. And we've seen that we have to start the sequence, and therefore we need two variables to start the sequence with. Now, how should this algorithm work? I decided to make here a simple flowchart to design a logical representation of the algorithm before going into code, and we'll also try to test this algorithm logically based on this flowchart. So of course we have a starting point, and as I said, we have to define the starting points. We'll define an integer a which is equals to 0 and an integer b which is equals to 1, and of course the counter that is equals to 15. Now what we have to decide right now is how we should proceed. Since we have a counter and we know that we have to generate a new number for each, let's say, digit of the counter, then we will need to use a loop. The next question would be, what kind of loop should we use? Now we could use while loop, but in the while loop we have to take care of the counter ourselves. So that's why I think it's better for now to use a for loop, because the for loop takes care of the internal counter itself. So we will initialize this for loop with the counter I equals to 0. So that is our starting point. Now, the next step we will have to evaluate, is I less than count, so less than 15. In this case, we have to perform some operations. And the first thing, we would define a new variable temp, which is a temporary variable, let's say, and we will assign to temp the value of a, which for the first iteration it will be 0. Then we will make a equal to b, then b will be equal to temporary plus b, and we'll write a to the console. Now, since in this flowchart we have also to take care of our internal counter, we have to increase the counter with 1. Now, of course, we will re-evaluate if I is less than 15, and if, or at the time that I will be greater than 15 or equal to 15, then we'll have to stop our program. Now, let's test this algorithm right now. So we have the starting point where we declare A and initialize it to 0, b equals 1, and the count equals 15. Now I equals 0 for the first iteration of the loop, so I is less than 15 because I equals to 0. In this case, we'll perform this type of operation. So we will make this temp variable equal to a equals 0, so temp will be equal to 0. Then a equals b, we see that b equals 1, so the new a will be 1. Then b will be temp plus b, so temp is 0, b is 1, so the new b will be also 1. Now we'll write a to the console and we'll increase the counter, the internal counter with 1, so it will be 1. Now if we look at what we have printed to the console for now, it is 1. When we go to the next step, we see that here we have a equals to 1, b equals to 1, and of course count is the same. The internal counter of the for loop, will be equal to 1, and we have to evaluate, is 1 less than 15? Of course it is less than 15, so in this case we go ahead and perform the same operation once again. So the new temp will be equals to a, so it will be 1, a equals to b, we see that b equals 1, so the new a will be 1. Then we have b, which is temp plus b, which is 1 plus 1, which is 2, of course, and we'll write a to the console, which is once again 1. So the next number in the sequence is 1, of course. Now we also have to increase the counter for the for loop, and it will be equal to 2. So for this iteration, we start with a equals 1, b equals 2, and count, of course, is the same, 15. And we saw that it is equal to 2 right now. So we have to evaluate, is 2 less than 15? Of course it is less than 15. So once again we have to perform the same action. So temp equals a equals 1 in this case. Then a equals b. Now the new b is 2, so a will be 2. And b will be temp plus b, so it will 1 plus 2, so b will be 3. And we will write a to the console and increase the counter. Now a is 2, so we have written it to the console and we increase the counter. The counter would be 3 right now. So if we go for the next iteration, a will be equal to 2 as a starting point, b would be equal to 3, and the counter would be the same. However, the internal for counter equals 3. Now, is 3 less than 15? Of course it is less than 15, so once again we go ahead and do the same thing. So temp equals a, which will be 2, a equals b, which will be 3, b equals temp plus b, which will be 5, and we'll write a to the console and increase the counter, and we will have 3 right now. So when we go to the next step of the iteration, we have a equals 3, b equals 5 as a starting point, the internal for loop counter equals 4, and is 4 less than 15? Yes, it is. And once again we perform the same type of actions, and what we see is that the new a will be equal to 5. So what we will print to the console is 5. And we won't go any deeper into this test because we already see that what we have printed is 1, 1, 2, 3, 5, which is a correct Fibonacci sequence. And we can assume that if we iterate further through the for loop, we will get a correct Fibonacci sequence. So that's how our algorithm is supposed to work. Let's now get our hands dirty and see exactly how we can translate this flowchart into a very small C# program. Coding the described algorithm shouldn't be very complicated. In fact, it should be fairly easy. So let's start. We said that we want to have the starting values int a equals 0. Then we have int b equals also 0. And we said that we also want a counter, which is also an integer. So it's int counter equals to 15. So that's it for now. Right now what we have to do, we said we have to start a loop, and we decided we'll use a for loop. So it's for int I small I equals 0. We start the loop with 0, then we go with this loop until I is less than counter, and we have the iterator which will increase the internal counter of the for loop with 1. And what we said that we have to do here is first we need a new int variable which we call temp, and it will be equal to a. Then a will be equal to b, so we will have a new value for a, and b will be equal to temp plus b, so we will also have a new value for b. Now we want to write a to the console. So we'll write console write a because we want all the numbers on the same line, and let's also add a space afterwards. And as for the algorithm, that should be mostly it. Let's however also include here a console write line, okay, and a console read line to make sure that we will keep the console open after the output is displayed. And for now, I think this should do it. If we run this program, we should see the first 15 Fibonacci numbers. Now here something went terribly wrong. So what we want to do is, of course, b equals to 1 is not equals to 0. Okay, let's run it again, and now it should be okay. And yes, in fact, we see that these are the first 15 Fibonacci numbers in the Fibonacci sequence. So that's very, very fine. Now let's do another fancy thing here. Let's, for example, check exactly how long does it take for this program to calculate this algorithm. So in order to do that, let's use the C# stopwatch. So let's declare a new stopwatch variable which will be sw equals to new stopwatch, and right before we start the for loop we have stopwatch.start, so that the stopwatch starts, and when we finish the loop, so when it will exit the loop, let's have sw stop, so the stopwatch stops right now. And also let's print the milliseconds to the console. So console write line sequence was generated in, and let's use string interpolation. We saw this also in another video. So sequence was generated in, and here we need okay, elapsed milliseconds, and that should be it. And let's run the program once again and see exactly in how fast our sequence is generated. So if we run it now, we see sequence was generated in 169 milliseconds. So I think something went here not so smooth because it should be faster, but we could try again, and I expect something 27 milliseconds, yet that is however better. Now I have to say something. Measuring elapsed milliseconds with a stopwatch is not necessarily a very accurate method to check exactly how fast an algorithm is, because here there are a lot of complicated things going on, like what other processes have I running on the computer, well, let's say the overall clock time that my algorithm gets, and so on. So stopwatch is certainly not very accurate, but however for beginners I think it might be useful in order to make a really short impression on how the algorithm is performing. But once again, you shouldn't use this as, let's say, a real benchmarking method. We can do benchmarking using different tools, but for now, this stopwatch I think will do it. However, before we wrap this up, I just want to make another short note. Let's, for instance, change the counter here from 15 to 48. And let's check what happens here. So the algorithm is exactly the same. But if when we generate the sequence, we see that the sequence is generated correctly, but at a certain point we start to get negative numbers. And of course, this is surely not right, because when we add two positive numbers, we cannot get a negative number. So what happens here? Well, here happens a very interesting thing. We have declared our variables, especially int a and int b. We have declared these variables as integers. Now, integers are a value type that, let's say, have a very specific memory allocation or a specific space memory allocation. So this means that we can store variables into an integer up to a certain threshold, let's say. And we can see that the threshold for an integer is at around 2 billion. And we can, for instance, try to see that console.writeLine. And if we, okay, the brackets are not correct. And here, if we print out int max value. So this would be the maximum value of an integer. And if you run this program right now, we will see that the max value for the integer is 2,147,000,000 and so on. So this is the value. And we see that this value is smaller than that. But if we add these two values, so this one with this one, it would be greater than this one. And that's why what we have here error messages, because C# is designed not to throw an error message in this case and try to do the calculations in some other way. So what is important to know when you want to generate a Fibonacci sequence in a program is that if you use integers as data type, then after the 47th Fibonacci number, you will get errors and the Fibonacci sequence won't be displayed correctly. So how we can solve this problem is, for instance, that we change the value type here from int to double. And let's change a to double, let's change b to double. The counter we can leave it as an integer. And here we have also changed the temp to be also a double. And doubles have a larger, let's say, memory allocation as space, let's say, than integers. So when we run this program now, it should print correctly all the numbers in the sequence. And in fact, we see that here it is printed correctly, and also the next one is printed correctly, and so on. So this is for you only to be aware. If you are using integers in your Fibonacci algorithm, then if you want to generate a sequence which is greater, let's say, than 47 elements, you will get errors and the sequence won't be displayed correctly if you are using integers. However, if you change your variables to be doubles and not integers, then the sequence should be displayed correctly. So that's it for now regarding Fibonacci numbers and a very simple algorithm to print out a sequence of Fibonacci numbers to the console. Thank you very much for watching. If you enjoyed this video, then please hit the subscribe button so that you stay up to date with new videos that we will upload. Also, if you have friends that might find this video interesting, then don't be shy and share this video on your social networks. And if you really found this video useful, also drop a comment. This would be very useful for me. Maybe let me know what do you expect in further videos. Maybe there are some topics that you would like to see on Developer Ramp Up and so on. And before we wrap this really up, I just want to make a short note at the end. There is a very nice channel on YouTube which is called Numberphile, and that channel is run is run by some guys that are very passionate about mathematics, and on that channel you will find a lot of videos, a lot of very interesting videos about the Fibonacci numbers, the golden ratio, and so on. So I would strongly encourage you to check that channel out and look at the videos that speak about Fibonacci numbers. You will have a link to the Numberphile YouTube channel in the description. Once again, thank you very much for watching, and until the next time, I wish you the very best.